Exams of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This is a great site for your entrance exam question papers. You must explore it because you have all the detailed PDF solutions over there. Also, you may download our app. The link is available in the description box for a better preparation of your exams. Student, today we'll be solving the VITEEE 2023 paper. I'll be solving the physics part in this particular paper. So here we go. Let's start with the first question. A very best of luck. Question number 1 says, light of wavelength lambda A, lambda B fall on two identical metal plates A and B respectively. The maximum kinetic energy of photoelectrons is K and Ka and Kb respectively. Then which of the following is true? You have lambda A is equal to twice of lambda B. Okay, so maximum kinetic energy, it is given by the formula hc upon lambda. This is Planck's constant, speed of light, wavelength minus W naught. So for the first one, Ka, that is the maximum kinetic energy for the photoelectron for plate A, is given by hc upon lambda A minus W naught. And you are given that lambda is equal to twice of lambda B. So this is hc upon twice of lambda B minus W naught. Similarly, you have Kb as hc upon lambda B naught minus W naught. So from 1 and 2, you clearly see that from 1 and 2, you have Ka is less than half of Kb. So that makes A option as the correct choice. Next is question number 2. Which of the following curves represents variation of impedance with frequency f in series LCR circuit? Impedance at resonant frequency is minimum in series LCR circuit. So you have Z is given by the root of R square plus 2 pi FL minus 1 upon 2 pi FC whole square. So when the frequency is increased or decreased, in both the cases, Z increases. This is not possible over here. This is not possible because in case of increase or decrease, the Z is decreasing, and this is the right one because in case of decrease or increase in the frequency, the Z is increasing. And this is even not. Option C is the correct answer. Hope you understood that. Let's move to the next question, number 3. A carrot engine takes 3 into 10 power 6 calories of heat from a reservoir at 627 degrees Celsius and give it to the sink at 27 degrees Celsius. The work done by the engine is, the efficiency of the engine is given by, efficiency of the engine is given by 1 minus T2 upon T1. You have a T1 as this 627. I'm changing it into Kelvin. So this is equal to 900 Kelvin. T2 is equal to 27. If I'm changing it to Kelvin, this is equal to 300 Kelvin. So the efficiency is given by 1 minus 300 upon 900. This is equal to 600 upon 900. Or this will give me approximately 2 by 3. Okay. Now, this efficiency is also equal to work done upon the heat. And we have to find out the work done. So work done is equal to efficiency into the heat. Efficiency, we just calculated. This is 2 by 3. And the heat is 3 into 10 power 6. 3 into 10 power 6. So this is in joules. So 3 into 10 power 6. If I have, this is in calories. If I have to convert into joules, this will be multiplied by 4.2. So this is 4.2 joules. This gives me on solving 8.4 10 power 6 joules. So you have option B as the correct answer. Hope you understood that. Let's move to the next question. Question number 4, an element of 0.05 I, this is I cap M, is placed at the origin as shown in the figure, which carries a large current of 10 amperes, distance of 1 meters in perpendicular direction. The value of the magnetic field is, so here the dB is given by mu naught upon 4 pi into I di sine theta upon r square. Here, V naught is your vacuum permeability, and the value is given by 4 pi into 10 power minus 7 h per m. So this is your current. Let's write down these values as well. So you have here di, this is equal to d delta x, which is equal to 0.05 meters, and current is 10 amperes. Sine theta, this is 90 degrees. So this is equal to sine 90 degrees, that is 1, and r is also equal to 1 meters from here, distance of 1 meters. Okay, so this is the one. Let's get back. We have to solve this. We have to find out the value of the magnetic field. This is given by dB is equal to 4 pi into 10 power minus 7 upon 4 pi into I, which is 10 di 0.05 into sine 90. This is 1 upon r square. This is 1 square. You have 10 power minus 7 into 0.5, or this is equal to 5 into 10 power minus 8. So here it is. Option C is the correct answer. Hope you got that. Let's move to the next question. Question number 5, the sinusoidal voltage of amplitude 25 volts, frequency 50 hertz is applied to a half-wave rectifier using PN junction diode. No filter is used and load resistor is 1000 ohm. Forward resistance RF of ideal diode is 10 ohm. The percentage rectifier efficiency is. First of all, let's find out IM. This is VM upon the total resistance. So RF plus the load resistor. This is given by 25 plus 100, 1000 plus 10. This will be approximately equal to 24.75 milliamperes. So IDC is equal to IM upon pi. This is 24.75 upon the pi is 3.14. This is 7.87 milliamperes. IRMS is equal to IM upon 2. This is 24.75 upon 2. This is 12.37 milliampere. Now, PDC, this is IDC square multiply RL. So this is 7.87 into 10 power minus 3 for removing this milli square multiply by 10 power 3. This is equal to 61.9 milliwatt. And power of AC is IRMS multiply RF plus RL. This is 12.37 into 10 power minus 3 square multiply 10 plus 1000. And this on solving will give you 154.4 milliwatt. So rectifier efficiency is given by this PDC upon PAC into 100. We have to find the percentage. So 61.9 upon 154.54 into 100. This is equal to 40.05%. So let's check with the options. 40.05. This is option A. This is the right answer to the question. Did you understand that? And hope you understand that. Let's move to the next question now. Question number 6, a flask contains monoatomic and a diatomic gas in the ratio 4:1 by mass at the temperature 300 Kelvin. The ratio of average kinetic energy per molecule of the two gases is. The average kinetic energy per molecule of any ideal gas is always equal to 3 by 2 kb into T. It depends only on the temperature and is independent of. It depends on temperature and is independent of mass and nature of gas. So the ratio of average kinetic energy per molecule of the two gases is equal to 1:1. Option A. Question number 7. The potential energy of the particle UX executing simple harmonic motion is given by the potential energy of any body which is executing the simple harmonic motion at any instant is given by U is equal to half into mass into angular velocity square into y square. If I take this as a constant k, so this is half into k y square. Now let's say the displacement y is equal to a minus x. Then this whole term will be equal to u is equal to half into k a minus x square, which can be written as this is ux for that particle. Ux is equal to half into k into x minus a whole square, which is your first option, option A. Hope you understood this. Let's move to the next question now. Question number 8, consider the electric field which is given by E naught x cap, where E naught is constant. Flux through the shaded area is due to the field is given by. Okay, first thing, the formula for the flux through the given area is given by the electric field multiplied by the projected area. Right, first of all, let's find the electric field. It is E naught over here given, and the area projected, that's given by A multiplied by cos of 45 degree. Now area, let's find out the area of this. This is a parallelogram. Area of the parallelogram, base into height. The base is A and the height. Now see, this is a three-dimensional figure. So the height, base for required area is equal to A, and height. See now, just imagine this is a 3D figure. So this height will be given by something like this. This is base. This is the Z component of it. This is again Z. This is the H, height. This is given by root of A square plus A square, which is equal to root 2 into A. So height is equal to root 2 into A. This is the area of required region is base into height, that is A into root 2 into A, which is equal to root 2A square. Let's fill in this equation. So flux is given by E naught into area, which is root 2A square, multiplied by cos 45, which is 1 upon root 2. So this is equal to E naught A square. This is the answer to the question. Flux is given by E naught A square, and you have C option as the correct answer. Hope you understood this. Let's move to the next question, number 9. It says the equation of a wave on a string of linear mass of density 0.04 kg per meter is given by this. Let's write down the equation. You have to find out the tension in the string. You are given the equation is equal to y is equal to 0.02 m sine 2 pi t upon 0.04 in seconds x upon 0.50 in meters. And if I compare it with the standard wave equation, comparing with the standard wave equation, you have y is equal to a sine omega t minus kx. So according to this one, you have omega as 2 pi upon 0.04 radians per second. K is equal to 2 pi upon 0.5 radians per minute, and velocity, wave velocity, that is v is given by angular velocity upon k. This is equal to 2 pi upon 0.04 divided by 2 pi upon 0.5 meters per second. So also, you know, velocity is equal to root of t upon mu. So here t is your tension of the string, and m is linear mass density. So let's fill in the values now. You have omega upon k is equal to root of t upon mu. This is equal to t is equal to mu omega square upon a square, or t is equal to, this is equal to 0.04 multiply 2 pi upon 0.04 square divided by 2 pi upon 0.05 square. This on solving will give you 6.25 newtons. So this is the answer to the question, 6.25 newtons, the tension. Option D is the correct answer. Hope you understood that. Let's move to the next question, number 10. Equipotential surfaces are given in the figure, then the electric field strength will be. So this is the given figure, and you have to find out the electric field strength. I'll be using dV is equal to minus E vector dot dr vector, and delta V is equal to minus E delta R into cos theta. You are given this figure. So let's use this. You have E as minus delta V upon delta R into cos theta. Let's fill in the values. This is equal to minus 20 minus 10. 20 minus 10 upon delta R. This is equal to 10 into 10 power minus 2 into angle is, see, this is cos, not sine. This is cos of 120. So this will give me, on solving, this is minus 10 upon 10 power minus 1 cos 120. This is equal to minus sine 30 degree, or this will be equal to minus 100 upon sine 30 degree will be equal to 1 by 2. So this is minus 200. Sorry, this is minus and minus. This will cancel. So here will be minus. This and this will cancel. 200 volt per meter. This is the answer to the question, 200 volt per meter and an angle of 120 degree with the x-axis. Option C is the right answer. Hope you got that. Let's move to the next question. Question number 10, equipotential surfaces are shown in the figure, then the electric field strength will be. So if I consider this part, here is 10 volt and 20 volt. This is your 30 degree, and even this is your 30 degree. Over here you have 4e, this whole theta, this is 4 times e. So this theta is equal to 120 degree. And this is your delta R. Now, according to the equation, I'll be using dV is equal to minus E dot dr. That means delta V is equal to minus E dr into cos of angle between them. Or E is equal to minus delta V upon delta R into cos of angle between them. So E is equal to voltage change 20 to 10 minus 20 minus 10, and delta R is again 10, 20 to 10 cos of 120 degree. This is equal to minus 10 upon 10. Cos 20 can be written as minus sine. Cos 120 can be written as minus of sine 30 degree. And this will give me minus okay, one more thing, I'll be converting because this was in centimeters. I have to do the conversion. This will be multiplied by 10 power minus 2. All right. So, yes, this will be minus 100 upon sine 130, which is equal to minus 1 by 2. Minus minus will cancel, and you will have 200 volt per meter. So 200 volt per meter at an angle of 120 degree with the x-axis, you have option C as the correct answer. Hope you understood that. Let's move to the next question. Question number 11, students, there is a change in the question. The statement over here has some things which are missing from here. So the right statement is waterfall from a 40-meter high dam at the rate of 9 to 10 power 4 kg per hour. 50% of the gravitational energy can be converted into electrical energy using this hydroelectric energy. Number of 100-watt lamps that can be lit. You are what? You have to take the value of G as this. So you know that half change in energy upon change in time is a, power of one bulb into the number of bulbs. That is, let's say n. Okay, this is what you need to find out in the question n. And you know one thing, that delta u upon delta t, this is equal to mgh upon 3600, because the time is taken as 1 hour. So this is 3600 joules per second. So let's fill in over here. This is equal to half into mgh upon 3600. Power of one bulb is equal to 100 into number of bulbs. M is 9 into 10 power 4, and the time per hour. So I'm taking 3600 seconds over here. Multiply G is 10, and the height is 40 meters. It's given in the question. This is equal to 100 into number of bulbs. All right. So now let's do the cancellations and everything. So this will cancel. This will also cancel. And you will have over here 1 by 2 into 10,000 upon 100 is equal to n, or n is equal to 50. Okay, so that means 50 bulbs can be lit using this. That makes B option as the right answer. Hope you understood this. Let's move to the next question, number 12. It says an electron mass given by this, charge given by this, moving with this velocity, enters the magnetic field. It describes a circle of radius of 0.1 m, then the strength of the magnetic field must be. All right, so you have to find out the strength of the magnetic field. Force is equal to BQV. When a charged particle of charged particle of mass m enters a magnetic field with density B at v velocity as v, then a force acts on it. And if the field is at right angles to the motion of the particle, then this force is given by magnetic field into charge of the particle into velocity. In simple terms, this is the force exerted by the magnetic field on a charged particle having the charges q moving with the velocity v. All right, so this is F. Also, you have, this is your magnetic force. So also this force is, magnetic force is equal to mv square upon r. This force is always right angles to the motion of the particle, and it is defined with the radius r. So from this you have p q v is equal to. Question number 12, an electron with the mass this, charge this, moving with the velocity 10 power 6 meters per second enters a magnetic field. If it describes a circle of radius 0.1 m, the strength of the magnetic field must be. So when a charged particle with the charge q, velocity v, is moving in a magnetic field with the intensity v, it exerts a force that is equal to BQV. Also, if the mass m is the mass of the particle, v, again the velocity, same thing. And it describes a circle. The particle deflected in a circle of radius r. So r describes the radius of the circle it describes. So this force is also equal to mv square upon r. Now these two are equal, so that means you have bqv is equal to mv square upon r. So let's fill in the values now. First of all, you have to find out the b. This is v, and v will cancel. You will have this as mv upon r into q. All the values are given to you in the question. Mass is 9 into 10 power minus 31. Velocity 10 power 6. Radius is 0.1, and charge on an electron defined as. So solving this, you have 5.5 into 10 power minus 5 t. This is option C. So this is the right answer to the question. Hope you understood that. Let's move to the next question number 13. If V1 is the velocity of the particle projected from point A and V2 is the velocity of the body projected from point B, which is vertically below the highest point C. Let's look over here. I'm reading the statement again. V1 is the velocity of the body projected from the point A. This is V1 initially, and V2 is the velocity of the body projected from point B, which is this is V2, okay, which is vertically downward at from C. If both the bodies collide, then which of the following is true? When the two bodies will collide at the highest point, the two bodies will collide at the highest point if both cover the same vertical height in the same time. Correct, right? Hope you agree with this. Two bodies will collide at the highest point when they cover same vertical height in the same time. Correct? V1 square into sine square. This is 30 degree. Question number 13. If V1 is the velocity of the body projected at the point A and V2 is the velocity of a body projected from the point B, that is this one, which is vertically below the highest point C. If both bodies collide, then which of the following is true? There is one thing. It is given in the question that this angle is equal to 30 degree. It's given in the question. So now let P be any point where they collide. Where they collide. Therefore, time taken by the object with the velocity v1 to reach P is equal to, let's say this is t1 time t2 taken by B with the velocity v2 to reach P. That means these both times are equal, and you can simply say t1 is equal to t2. What is T1? This is V1 upon G into sine of 30 degree. This is a vector quantity. So V1 along this line, this is V1 into sine 30 degree. This is the horizontal factor of this V1 velocity. This is equal to V2 because this is vertically going upwards. So this is into sine 90. That becomes V2 upon G into sine 90 degree. And these two things, they will cancel. And you have V1 sine 30 degree is equal to 2. And this is equal to V2. Or what you need to find out is V1 upon, okay, you have a V1 is equal to, no, this is the one. Option B. V2 is equal to half of V1. This is the right answer to the question. Hope you understood that. Let's move to the next question now. Square frame of side 10 centimeter and a long straight wire carrying a current of 1 ampere in the plate of the paper are in a plate of paper. Starting from close to the wire, the frame moves towards the right with a constant speed of 10 meter per second. The EMF induced at the time left arm of the frame is at 10 centimeter from the wire is. So let's write down the things which are given. You have a current flowing through the wire, that is 1 ampere. Speed of the frame 10 meters per second. Also side of square loop, that is 10 centimeters. Distance of square frame from current carrying wire is also 10 centimeter. You have to find out induced EMF. So according to Bio-Savart's law. You have B is equal to mu naught upon 4 pi into I di sine theta upon x squared. So you have mu naught is 4 pi into 10 power minus 7 upon 4 pi into current is 1 di 10 raised to power minus 1. This x is also, because this, see, this is 10 centimeter, this is equal to 0.1 meters, 0.1 meters. So you have this as 10 raised to power minus 1 whole square. This is equal to, on solving, this will give you 10 raised to power minus 6. So induced EMF, that is E is given by B into B into L into V. This is equal to 10 power minus 6. Length is 10 power minus 1 into 10. That is equal to 1 microvolt. So you have option B as the correct answer. Hope you understood this. Next is question number 15. For a circuit shown in the figure, the current flowing through the inductor is 0.9 ampere while the current through the condenser is 0.4 amperes. Then which of the following is correct? Okay, this is the circuit. One thing, that is current drawn by the inductor and capacitor will be in opposite phase. Hence, net current drawn from generator will be IL minus IC, which is 0.9 minus 0.4. That is 0.5 ampere. So you have C option as the correct answer. Hope you understood. Next is question number 16. The ozone layer in the atmosphere absorbs only the radio waves, only the visible light, only the gamma rays, or X-rays and the ultraviolet rays. It is X-rays and the ultraviolet rays. Ozone layer, it absorbs your ultraviolet and the X-rays. Option D stands to be the correct answer to the question. Next is question number 17. The PV diagram of the diatomic ideal gas system going under cyclic process is as shown in the figure. The work done during the adiabatic process CD is, okay, so work done during adiabatic process CD is given by PC VC minus PD VD upon this. This is equal to 100 in the figure. This is 100 into voltage is, let's see it over here. Voltage is 4. What is 100? Minus PD, that's 200 into 3 upon 1.4 minus 1. This is equal to 400 minus 600 upon 0.4. And this is equal to minus 200 into 10 upon 4, or this is minus 500 joules. So you have A option as the correct answer. Hope you got that. Next is question number 18. In Young's slit experiment, how many maximas can be obtained on a screen, including central maxima in both sides of the central fringe if lambda is 3000 angstrom and D is equal to 5000 angstrom. So you have here that lambda is less than D is less than 2 lambda in this case. So delta X max is equal to this D and gamma as 1. So the work done during adiabatic process is given by PC, VC minus PT, VT upon gamma minus 1. PC is over here, this is 100 multiply 4 minus PD is 200 multiply 3 divided by 1.4 minus 1. This is equal to minus 200 upon 0.4. This is minus 200 into 10 upon 4, or this is equal to minus 500 joules. That makes first option to be the correct answer. Next is question number 18. In youngster double slit experiment, how many maximas can be obtained on a screen, including central maxima in both sides of the central fringe? If you are given that lambda is equal to 3000 angstrom and D is equal to 5000 angstrom. So delta X max, this is given by D, which is 5000 angstrom, and you are given lambda is equal to 3000. In the question, you have lambda is less than D is less than 2 lambda. So number of maximas that can be obtained on the screen, including the central maxima, is 3. Option C is the correct answer. Hope you got that. Next is question number 19. A and B are two metals with the threshold frequencies this and this. Two identical photons of energy this much each are incident on them. The photoelectrons are emitted in B alone, A alone, neither A nor B, both A and B. 19, A and B are two metals with threshold frequencies given by this and this. Two identical photons of energy this much are incident on them. Then the photoelectrons are emitted in B alone, A alone, neither A nor B, both A and B. So you are given, let's write down, you are given the threshold frequency for A metal is 1.8 into 10 raised to power 14 hertz, and for B this is 2.2 into 10 raised to power 14 hertz. Energy is given to you as 0.825 electron volt converted. So this is 0.825 into 1.6 into 10 raised to power minus 19 joules. There's the energy also frequency of incident photon is given by E is equal to h mu, or mu is equal to E upon h. E is 0.825 into 1.6 into 10 raised to power minus 19 divided by h. This is 6.6 into 10 raised to power minus this. This on solving will give you 2 into 10 raised to power 14 hertz. Now the frequency, threshold frequency for A was 1.8 into 10 raised to power 14 hertz. And for B, this is equal to 2.2 into 10 raised to power 14 hertz. See, the photoelectrons will be emitted from the metal surface if the frequency of the incident photon is greater than the threshold frequency. And here you notice that this frequency is greater than frequency for the metal A, and the frequency for the metal, this frequency is less than for this. In the case of metal B, this is for A metal. Threshold frequency of A metal is less than the incident frequency of the incident photon, and the threshold frequency for the metal B is greater than this frequency of the incident photon, right? This is for the B metal. So that means photoelectrons will be emitted from only A. That makes B option to be the right answer. Hope you understood this. Let's move to the next question. Question number 20. A sinusoidal voltage of amplitude 25 volt, frequency 50 hertz is applied to a half-wave rectifier through PN junction diode. No filter is used and the load resistor is 1000 ohms. The forward resistance RF of the ideal diode is 10 ohm. Percentage rectifier efficiency is. Here in the question you have I of M is equal to Vm upon this resistance of the load resistor plus the forward resistance. This is equal to 25 volt, because this is your voltage 25 volt, and divided by 1000 plus 10, that is equal to 24.7 milliamperes. Also DC current is given by Im upon pi. Im is equal to 24.75. Pi is equal to 3.14. This one solution will give you 7.87 milliampere. IRMS is half of Im. This is equal to 2.75 upon 2, or this is equal to 12.37 milliampere. Therefore, you have a power DC is equal to I into RL. This is 7.87 into 10 power minus 3 whole square into, this is square into 10 power 3. This is equal to 61.9 microwatt. And AC power is IRMS square RF plus RL. This is 12.37 into 10 raised to power minus 3. I'm converting this milli over here. Right, this was in the milliampere, so I'm conversion this milli, which is 10 raised to power minus 3 whole square into, this is equal to 10 plus 1000. So on solution, this will give you 154.554 megawatt. Therefore, the rectifier efficiency is given by PDC upon PAC into 100. This is 61.9 divided by 154.54 multiply 100. This is equal to 40.05. So that makes option A to be the correct answer. Hope you understood this. Let's move to the next question, number 21. The force between two short bar magnets with magnetic moments M1, M2, whose centers are R meters apart, is 8 Newton when their axes are in the same line. If the separation is increased to 2R, the force between them will be reduced to. Okay, first thing, this force in the bar magnets with the momentums M1, M2, which are centimeters apart, force is inversely proportional to the fourth power of the R, distance between the centers. And now you are given that if this distance is increased to 2R, so that means it will be now F dash, this is inversely proportional to 2R power 4, or this is equal to 1 upon 16 R4. So let's divide both of them. You will have F upon F dash is equal to 16 R4 upon R4. So this is equal to 16. So F dash is equal to F upon 16. Now F is equal to 8. So this is equal to 0.5 newtons. That makes D option as the right answer. Hope you got that. Let's move to the next question. Question number 22. In a Rutherford scattering experiment with a projectile of charge Z1 mass M1 approaches a target nucleus of charge Z2 mass M2. The distance of the closest approach is R0. The energy of the projectile is. Now here you have two things. The particle of mass M1 and charge Z1. They possess the initial velocity V, U, possess initial velocity U when it is at a very large distance from the nucleus of an atom with atomic number Z2. Now, at the distance of the closest approach, the kinetic energy of the particle is completely converted into the potential energy. So kinetic energy, which is given by half mv square, this becomes equal to potential energy. This is 1 upon 4 pi E naught into Z1, Z2 divided by R naught, that is the distance of the closest approach. So what you have to find out energy of the projectile. This energy of the projectile, this is directly proportional to Z1 and Z2 product. That makes A option as the right answer. Hope you understood this. Let's move to the next question, number 23. What will be the maximum speed of the car on the road? Turn of radius 30 meters if the coefficient of friction between the tires and the road is 0.4. You have to take the value of G as 9.8 meters per second. Now, In the question, you have R as 30 meters and the coefficient of friction is given as 0.4. Maximum velocity is given by root of mu R G. So this is 0.4, 30. This is 9.8. On solving this, you will get 10.84 meters per second as the answer. That makes first option as the correct answer. Hope you got that. Let's move to the next question. Question number 24. A person aiming to reach the exactly opposite point on the bank of the stream is swimming with the speed of 0.5 meters per second at an angle of 120 with the direction of flow of water. That is the direction of the flow of water and this is the opposite side of the stream. The person is swimming, and obviously he wants to reach, he will have this path while swimming. This is the velocity of the man and this is the velocity of the stream. Let's say V are the velocity of stream and Vm be the velocity of the person. So you are given in the question that this angle is equal to 120. Let's divide it. So this angle, this is 90-degree angle, this will be 30-degree angle. Then you have sine 30-degree is equal to VR upon Vm. This is equal to 1 by 2 VR. I have to find out Vm is 0.5. So this will be equal to, okay, 1 by 2 into VR into 1 by 2 by 1. Right. So this gives you VR is equal to 1 by 4 or this is equal to 0.25 meters per second. This is the speed of the stream. That makes option, let's check with the options now. That makes the C option to be the right answer. Hope you got that. Let's move to the next question. Question number 25. A car moves at the speed of 20 meters per second on a bank track and describes an arc of the circle of radius this much. The angle of banking is. So you have the velocity as 20 meters per second. The arc of radius is 40 root 3 meters, gravitational constant 10 meters per second square. We know that angle of banking is given by angle of banking is tangent of theta, which is given by v square upon r into g. V square is 20 into 20 upon R is 40 root 3 G is equal to 10. So this will give me this, these two things will cancel and this also will cancel. So this is equal to 1 upon root 3. This gives you tangent theta is equal to 1 upon root 3, which makes theta is equal to 30-degree. So you have option D as the right answer to the question. Hope you understood this. Next is question number 26. If a force of given a force which is given by this vector is acting at a point R, which is given by this vector, the value of alpha for which the angular momentum about the origin is conserved is, okay, I'll use the Newton's second law of rotational motion. Newton's second law of rotational motion. This is given as a torque is equal to change in angular momentum upon with respect to time. In the question, you are given the value of alpha for which the angular momentum is conserved, which means angular momentum is a constant. If this is constant, then this terms become equal to 0. That means the torque is equal to 0. And you also know that torque is equal to cross product of R and F. That means this is also equal to 0. R is given by 2I minus 6J plus minus 12K cross alpha I 3J 6K. This is equal to 0. So let's solve it. You have I, J, K, this is 2 minus 6 minus 12, alpha 3 and 6. This is equal to 0 determinant. So this will give me this minus 36 plus 36 minus J 12 plus 12 alpha plus K 6 plus 6 alpha is equal to 0. This thing is equal to 0 minus 12. I'm taking common. J1 plus alpha plus 6k 1 plus alpha is equal to 0. From here you have 1 plus alpha is equal to 0. That gives you alpha is equal to minus 1. Right. So you have the option as the right answer. Hope you understood this. Next is question number 27. A convex lens has a part P. It is cut into two halves along the principal axis. Further, one piece out of the two halves is cut in two halves perpendicular to the principal axis as shown in the figure. You have to choose the incorrect option for the reported pieces. Okay. So according to the question, first of all, it is cut into two halves according to the it is cut into two halves along with the principal axis. Then further it is cut into two halves perpendicular to the principal axis, that is your vertical axis. Now, if a lens, do remember this thing, if a lens is cut in two halves, two halves along the principal axis, focal length is unchanged. Focal length remains unchanged. Only what changes is intensity of image. Only intensity of image changes in that case, decreases. Okay, so power of L1 will remain unaffected. It will not change because power is inversely in proportional to the frequency and frequency does not change. So power will also not change. Therefore, if you are saying that the power of L1 become half of P2, this is wrong. This statement is the correct answer because this statement is wrong and this is what it was asked in the question. Hope you understood this. Let's move to the next question now. Question number 28. A ball of radius r and density rho falls freely under gravity through a distance h before entering water. Velocity of the ball does not change even on entering the water. The viscosity of the water is eta. The value of h is given by. So you have a velocity of ball when it strikes the water surface is given by v is equal to root of 2gh. Also, the terminal velocity of ball under the water v is equal to 2 upon 9 r square g rho minus 1 upon eta. Let's say this is equation 1 and equation 2. Now in the question it says the velocity does not change. So according to the question, these two are equal. That is root 2gh is equal to 2 upon 9 r square g rho minus 1 upon eta. Let's do squaring on both the sides. You have 2gh is equal to 4 upon 81 r power 4 g square rho minus 1 upon eta whole square. This g and g will cancel. This will be 2 over here. And you will have h is equal to 2 upon 81 r power 4 rho minus 1 upon eta whole square into g. So this is the answer to the question. You have this one option as the correct answer. Option C is the right answer. Hope you understood that. Let's move to the next question. Question number 29. The pressure inside a tire is 4 times that of atmosphere. The tire bursts suddenly at the 300 Kelvin. What will be the new temperature? See, under the adiabatic change, what you have is T2 upon T1 is equal to P1 upon 2 to the power 1 minus gamma upon gamma. Or this can be written as T2 is equal to T1 into P1 upon P2 raised to the power 1 minus gamma upon gamma. So you have T2, T1 is 300 Kelvin and this is 4 times the previous atmosphere. So you have this as 4 upon 1, 4 times that the pressure inside a tire is 4 times that atmosphere. So P1 upon P2 is equal to 4 upon 1. This is equal to 1 minus lambda is equal to 1.4 for air, or this is equal to 7.5. So this is 1 minus 7 by 5 divided by 7 by 5 to the power, or this is equal to 300 into 4 power minus 2 upon 7. That is equal to, I think I don't need to solve it further. The options are like this only, right? This is not 27, this is 2 by 7 we have. That makes D option as the correct answer. Hope you understood this. Let's move to the next question, number 30. It says a parallel plate air capacitor of capacitance C is connected to a cell of EMF V and then disconnected from it. A dielectric slab of dielectric constant K, which can just fill the air gap of the capacitor, is now inserted into it. Which of the following is incorrect about it? Okay, so first of all, let's understand the situation. A parallel plate capacitor having the capacitance C, this is connected to a cell of having EMF V and then disconnected. Dielectric slab of dielectric constant K, which can just fill the air gap of the capacitor, is not inserted into it. Okay, see, first of all, what is initial charge? Charge is given by Q is given by C into V. Now, after inserting dielectric with dielectric constant K, dielectric constant as K, the capacitance will become K times of the initial capacitance. So capacitance C dash will become K times the initial capacitance. Let's say that is C. Now, charge will remain the same as the cell is disconnected. Charge will remain same as cell is disconnected and capacitor is isolated. That means the charge is conserved, right? So the new capacitance we talked, that is equal to K times the initial capacitance. New potential difference is new potential difference. This is given by V dash is equal to Q upon K into C, or this is equal to V upon K. Initial energy is given by Q square upon 2C. Final energy is given by Q square upon 2KC, that is equal to initial energy upon the K. Now change in energy will be final minus initial. Change in energy will be UF minus UI, or this is Q square upon 2KC minus Q square upon 2C. I'll take Q square upon 2C common. This will be 1 minus K minus 1, 1 upon K minus 1. Or this is equal to 1 upon half CV square. And like this. So now let's look at the option. It says the energy stored in the capacitor becomes K times. That's right. The change in energy stored is half the CV square into 1 upon K minus 1. That's also correct. The charge in the capacitor is not conserved. No, this is conserved. This is wrong. The potential energy between the plate decreases K times. This is also right. So that means you have to find out the incorrect one, which is option C, because this is the incorrect option. Hope you understood this. Let's move to the next question, number 31. Oh, okay. Sorry. We are completed with all the 30 questions of the physics section now. Hope you understood them well, and don't forget to visit our website www.examsnet.com. Here you will find so many entrance exam question papers along with the detailed PDF solutions for your practice. So students, keep shining, keep rising high, and don't forget to visit our website. That's all for this paper. Bye. Question number 30, a parallel plate here capacitor of capacitance C is connected to a cell of EMF V and then disconnected from it. A dielectric slab of dielectric constant K, which can just fill the air cap of the capacitor, is now inserted in it. Which of the following is incorrect? So first thing, you have the initial charge is given by Q is equal to CV. Now after inserting dielectric with constant K, dielectric with the constant as K, the capacitance will be equal to K times the initial capacitance C. Now charge will remain the same as the cell is disconnected and the capacitor is isolated. So charge is conserved, or it's hand. Okay. Conserved or remains same as the cell is disconnected and capacitor is isolated. Okay, so you have the new capacitance as equal to K times the initial capacitance. Now, the new potential difference, that is V dash, is equal to Q upon KC, that is equal to V upon K. Also, initial energy is given by Q square upon 2C, and the final energy is given by UF is equal to Q square upon 2kc. That is equal to UI upon K. Now change in energy is equal to final minus initial energy. Change in energy is UF minus UI, that is equal to Q square upon 2kc minus Q square upon 2c. I'll take Q square upon 2c common. I have 1 upon K minus 1, and this can be written as half CV square 1 minus 1 upon K minus 1. So now let's look at the options. The first one says energy stored in the capacitor decreases K times. That's right. Yeah, that's right. Next, the chance, no, it's a change in energy stored is half CV square into 1 upon K minus 1. That's also right. We just solved this. The next one, the charge on the capacitor is not conserved. No, the charge on the capacitor is conserved. We have just discussed this over here. And the last one, it says the potential difference on the plate becomes K times. So this is also right. That makes option C to be the right answer, because this is the option which is incorrect. The charge on the capacitor is not conserved. No, the charge on the capacitor is conserved because the cell is disconnected and the capacitor is isolated. Right. So option C is the right answer to the question. Hope you got that. Next is question number 31. You are given a ray of light suffers minimum deviation in an equilateral prism. The additional prism Q and R of identical shape and same material as P are added as shown in the figure. The ray will now suffer what? Greater deviation, no deviation, same deviation as before, or it suffers total internal reflection. Let's make a ray over here. So when this ray enters P, it goes parallel to the base, same way here and same way here. Wait, same way here and here in this direction. There will be no refraction from P to Q, no refraction from P to Q and Q to R, no refraction again because all are of the same material. They are same, exactly same material, same prisms. They are exactly identical. So no refraction from P to Q and from Q to R. Hence the ray will now have the same deviation as before. That is option C. So this is the right answer to the question. Hope you understood this. Next is question number 32. If M is magnetic moment and B is magnetic field, then the torque is given by. See, if M is the magnetic moment and B is the magnetic field, the torque is simply given by the cross product of these two vectors. That is option C. It was pretty easy question actually. Let's move to the next question. Question. Yeah, an alpha particle of 10 micro, this is a milli-electron volt collides head on with a copper nucleus Z is equal to atomic number is equal to 29 and is deflected back. Then the minimum distance of approach between the center of the two is. So you are having alpha particle has charge of has Question number 33, an alpha particle of 10 MeV collides head-on with the copper nucleus having the atomic number 29 and it's deflected back. Then the minimum distance of approach between the centers of the two is. You are having that the alpha particle is has energy is equal to 10 MeV, which is equal to 10 into 10 power 6 into electron charge 1.6 into 10 raised to power minus 19 joules. So see, when it is having the head-on collision, then the minimum distance of approach between the two, one you are having the at the time of the distance of the closest approach at distance of closest approach, all the kinetic energy changes into the potential energy. So this energy, which was existent, which was consisted by this alpha particle, this energy is equal to K into ZE into 2E divided by the distance between them. You had to find out the distance. So D is equal to K is this atomic number 29 into 2 into electron charge 1.6 into 10 raised to power minus 19 E square because you are having 2E divided by 10 into 10 power 6 into this into this. So this thing and this thing will cancel. And on solving this, you will get that D is equal to 835.2 into 10 power minus 17 meters, or this is equal to, this was in, wait. Okay. 8.4 into 10 power minus 15 meters approximately, right? That makes option B as the correct answer to the question. Hope you understood that. Let's move to the next question, number 34. A planet in a distant solar system is 10 times more massive than the Earth and radius is 10 times smaller. Given that the escape velocity from the Earth's surface is this much, the escape velocity from the surface of the planet will be given by. You know one thing, that the escape velocity for the, let's say Earth, this is given by root of 2g mass of Earth divided by radius of Earth. Similarly, the escape velocity for the planet, it is given by 2g into mass of planet divided by the radius of the planet. Let's divide both of them. You will have a VE for the planet, escape velocity for the planet divided by for the Earth is equal to root of 2gmp divided by rp divided by root of 2gme upon re. So this is equal to mp into re upon n E into RP. Now you are given in the question that the distance is 10 times, it's 10 times more massive. That is, the mass is 10 times and the radius is 10 times smaller. That means MP is equal to 10 of MP. ME, also the radius of the planet is equal to the radius of the Earth divided by 10, according to the question. So this is equal to MP is equal to 10 ME into R of E divided by ME into RP is RE upon 10. Let's do the cancellations. So you will have root of 100, that is equal to 10. That means escape velocity of the planet is equal to 10 times escape velocity of the Earth, and escape velocity of the Earth is 11. This is equal to 110 kilometers per second. So that makes 110 kilometers per second. You have C option as the correct answer. Hope you understood that. Let's move to the next question now. Question number 35. In a figure, two equal positive point charges Q1 and Q2, which each are equal to 2.0 microcoulomb from here, interact with the third charge Q, that is 4 microcoulomb. The magnitude as well as direction of the net force on Q is equal to. All right, fine. So see, this is the force. Let's say this is applying this charge Q1 is applying of this is the charge Q, and they are moving in this direction. Then this is the net force for Q1 and Q charges. And let's say this is force exerted by the charge 1 on 3, and this is for second charge on the third one. Now in the question we are given that these two charges are equal and they are equal to 2 coulomb, and this Q charge, that's the Q3 charge, that is equal to 4 coulombs. All right. If this angle is equal to alpha, this angle is also equal to alpha. Now, first thing, you just have to note down this distance is 0.3. This is also 0.3. This is 0.5. This is 0.4. And even this is 0.5 meters. So first thing, the tangent of alpha is given by the perpendicular upon base, that is 0.3 upon 0.4, or this is equal to 3 by 4. And the cos of alpha is equal to base, that's 0.4 upon 5, that is equal to 4 upon 5. And the net force will be given by 2 into force exerted by the first one on the third one. That is, let's say this Q as the third charge. Okay. So force exerted by the first into the third, and this is for the second to on the third. So I'm adding them. So this will be twice of the forces exerted multiplied by the cos of angle between them. Right. This is equal to 2 into K into the charge Q1 or Q2, whatever you want to write, into the charge capital Q divided by the distance between them, that is equal to 0.5 square. Cos of angle is 4 by 5. So now this is equal to 2 into 9 into 10 power 9. First charge 2 microcoulomb. So 2 into minus power 10 power minus 6. The capital charge is 4 microcoulomb. So 4 into 10 power minus 6. This is equal to 0.25 multiplied by 4 by 5. Okay. Now this one solving will give you 460.8 into 10 power minus 3 Newton, or this is equal to 0.4608 Newton. In the direction, of course, this is a direction X for it. So you have option B as the correct answer to the question. So students, with that, we have completed all the 35 questions of the physics section for this particular paper. Hope you understood them well, and don't forget to visit our website www.examsnet.com. Here you will find this one and so many entrance exam question papers. You must download our app for the better preparation of your examination. The link is available in the description box. So very best of luck. Keep shining, keep rising high. That's all for this paper. Bye. Hey, chance of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great place for you to study all your entrance exam question papers. This is your one-stop destination. Also, you may download our app. The link is available in the description box for a better preparation. Students, today we'll be solving VITEEE 2023 paper. In this paper, in this particular video, I'll be solving the chemistry questions. So let's start with the very first question, chemistry questions. A very best of luck. Here we go. First question says you, which of the following sets of quantum numbers is correct for the electron in the fourth orbital? Um, See the possible quantum numbers for the 4f electron. This is 4f orbital. Okay. The possible quantum numbers for 4f electrons, number of possible quantum numbers is given by L is equal to 4, L is equal to 3, M is equal to -3, -2, -1, 0, 1, 2, 3, and S is equal to plus minus 1 by 2. Looking at all these ones, we have first option as the right answer. Hope you understood that. Next is question number 37. Arrange the following in increasing order of ionic radii. All of the given species are isoelectronic. In this case, in the isoelectronic species, ionic radii increases with the increase in the negative charge on the anions. That makes, if I look at this one, that makes, first of all, you have fluorine, then oxygen, followed by N-3, followed by C power 4. This is C option. So this is the right answer to the question. Hope you got that. Next is 38 question. The bond dissociation energies of X2, Y2, XY are in the ratio this. Delta H for the formation of XY is minus 200 kilojoules per mole. The bond dissociation energy of X2 will be. Okay, the bond dissociation energies of X2, Y2, X1. They are 1.5 and 1. Let's say this is X, this is 0.5x, and this is X. All right, this is X kilojoules per mole. Now, according to this, if I say this is X and this is half of X and this is X, so this can be written as a, if I apply the equation, this is x2 plus y2 gives you xy. If I want to take 1 of xi, that means I have to take half the molecules of x2 and y2. In this case, delta H for the formation of xy, 1 mole of xy will require half moles of this, half moles of this. So in this case, delta H is given to you as 200 kilojoules per mole. All right. So delta H, that is equal to summation bond dissociation energy for the reactants minus bond energy. Question number 38, the bond dissociation energies of X2, Y2, XY are in this ratio. If delta H for the formation of XY is minus 200 kilojoules per mole, the bond dissociation energies of X2 will be. First thing, you are given the bond energies for X2, Y2 and XY. They are 1.5 and 1. Let's say this is X, this is 0.5x, and this is X kilojoules per mole. Let's write down the reaction. You have X2, Y2. If I want 1 mole of this, so this will be half of X2, half of Y2 will give you XY. Now you're given that change in enthalpy in this case is equal to minus 200 kilojoules per mole. So that means this delta H, this is equal to summation of bond energies for the reactants. Wait, my pen is not working. Minus summation of bond energies of your products. Okay, so let's write down that. Now bond energies of the reactants is equal to half of X plus half of 0.5 Y minus 1 into xy. Okay, so this is equal to, on solving, you are given that this is equal to minus 200. This is equal to minus 200. Sorry, this is bond energy was taken to be x. It's given over here. This is x, this is point x, and this is x. So I have to take this as x. This is 0.5x, and this is x. Again, I'll write it properly. This is half of, for x, this is half of x. For y, this is half of 0.5x, because the bond dissociation energy of y is equal to 0.5x minus 1 into bond dissociation energy of the product, that is equal to 1 again, or x again. So this is equal to, on solving, you will have this as I'll take 1 by 2x plus 1 by 4x minus x. Let's take the LCM. You have 2x plus x minus x. This is equal to minus 200, or you will have minus 4x over here. Minus 800 is equal to minus x, or x is equal to 800 kilojoules per mole. So the right answer to the question is option D. Hope you understood this. Let's move to the next question. Question number 39, value of dissociation constant Ka for the following is given. For HCN, it's hydrogen cyanide, it's this. Hydrogen fluoride is this. Hydrogen nitride, it is this. And the correct order of decreasing base strength of these bases will be, see, what higher the value, higher the value of Ka, lower be the value of pKa. Okay, wait, this is higher the value of Ka, lower will be pKa. That is, the higher will be the acidic nature further, since Cn minus F minus NO2 minus are conjugate bases of HCN, HF, HN, and HNO2 respectively. Hence, the correct order of the base strength will be given by fluoride less than NO2 minus less than Cn minus, because stronger the acid, weaker will be the conjugate base. That makes C option as the correct answer. I'm repeating the whole question. Higher the value will be of higher the value of Ka, lower will be the value of pKa. That is, higher will be the acidic nature of it. Further, you are having Cn minus, F minus, and NO2 minus. They are the conjugate bases of these acids. Therefore, stronger is the acidic, stronger is the acid, weaker will be the conjugate base. That makes this series as the right answer. Hope you got that. Next is question number 40. The products formed when diborane is hydrolyzed is. So when the diborane is hydrolyzed, the reaction will be something like this. It is B2 H6. When it is hydrolyzed, it will give you H3BO3 plus H2. Let's balance the equation. You have this 6, and here will be 2, here will be 3. Hydrogen gas will be liberated. So this is the one that makes, that gives you the products as, these are the two products, hydrogen and, yeah, these are the two products, hydrogen and orthoboric acid. So C option is the right answer. Hope you understood that. Let's move to the next question now. Question number 41, the compounds this and this, they are what? They are tautomers, they are positional isomers, contain the same number of sp3, 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 sp2, sp2, sp2 carbon-carbon bonds, or exist together in dynamic equilibrium. See, the two isomers which differ in the position of the double bond, like over here, this is double bond at this place, and here the double bond is at this place. So the two isomers which differ in the position of the double bond, they are called positional isomers. So these are the positional isomers. Option B makes the right answer. Next is question number 42. You have to choose the correct option. So let's do the reaction. Let's complete the reaction. First of all, this is the given compound. This is CH3, CH2, CH2, CH3, CH3. Now this one reacts with HB2, H6, H2O2 and hydroxyl ions. This gives you CH3, CH3. Here will be CH3, here will be CH2, and here will be CH2OH. All right, this is your B product, and this is anti-Markovnikov product. All right, so this is your product B. This is having your anti-Markovnikov product. Let's go with the second one. Here is again, you have this CH3, 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 CHOH, CH3. Question number 42, choose the correct option for the following reaction. So this is your reactant, and when it reacts in the presence of these, and it will give you B, and in the presence of these, it will give you A. All right. So let's go for the reaction. First of all, you are having this CH3, 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 CH, CH2 in the presence of HB2, H6, H2O2 and OH negative. It gives you CH3, 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 CH2 and CH2OH. Right, this is your product B. This is anti-Markovnikov product. And the same reactant, this, when reacts in the presence of these, it will give you A. Let's write it down. You have CH3, 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 CH2 in the presence of HGOA. It is C2, water, NaBH4. It gives you CH3, 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 CH double bond, CH 2. And here will be OH. Right, this is your A product, and this is Markovnikov product. So your A is Markovnikov product and B is the anti. You have B option as the correct answer. Hope you understood this. Let's move to the next question. Question number 43. Which of the following has Frankel defect? Sodium chloride, silver bromide, graphite, and diamond. Before answering the question, I would like to talk about the Frankel defect. A Frankel defect is a form of point defect which is created when an atom or cation leaves the original place in the lattice structure to create a vacancy while occupying another interstitial position within the solid crystal. For the main conditions for the Frankel defects are coordination number should be low, and the size of the anion should be bigger than cation. Size of anion should be bigger than the cation. These are the two conditions. So Frankel defects are mostly exhibited in the ionic solids where the smaller ion, usually the cation, is dislocated. For example, silver bromide. Here the defect occurs mainly due to the smaller size of the silver ions. Meanwhile, the silver bromide also shows this effect. That makes B option as the correct answer. Hope you understood this. Next is question number 44. An element X has body centered at BCC structure with a cell edge of 200 picometers. So you have, this is as 200 picometers, that is 200 into 10 power minus 10 meters. The density is given to you as 5 gram per centimeter cube. The number of atoms present in 300 gram of X, you are given the Avogadro's number as 6.0 10 power 23 per mole. Right. Now the density is given by the formula Z into M upon A cube into Na, where Z is number of particle in unit cell. This is mass, and A is edge, and this is Avogadro's number. So let's go back to this equation. You had D is equal to this. What I had to find out is mass. This is equal to D into A cube and A upon Z. Here for the BCC structure, you have Z is equal to 2. Density is 5. Multiply A is 200 into 10 power minus 10 raised to power 3. Avogadro's number 6.0 into 10 power 23, and Z is equal to 2. So this gives it on solving, you will have a, let's see, this is 5 into 8 into 10 power 6 into 10 power minus 30 into 10 power minus 23. Okay, so this is equal to 40 into, I hope, yeah, this 3 is left. So this is 40 into 3 into 10 power, not minus 23, 10 power 1 minus 1. So this is equal to 120 into 10 power minus 1. This is equal to 12 grams. So mass is equal to 12 gram. That means 12 gram of element contains Na atoms. 300 gram will contain Na into 300 upon 12, which is equal to 6 into 10 power 23 into 3. I think the answer is in Na only. Okay, I will not change this Na. This is equal to 25 into Na. So you have option D as the correct answer. Hope you understood. Let's move to the next question now. Question number 45. On passing current through two cells connected in series containing the solution of silver nitrate, so copper sulfate, 0.18 gram of silver is deposited. The amount of copper deposited is, so to answer the question, I'll be using the Faraday's second law of electrolysis. Faraday's second law of electrolysis, it says weight of copper deposited upon weight of silver deposited is equal to equivalent weight of copper divided by equivalent weight of silver. So you have a weight of copper upon the weight of silver deposited is equal to 0.18. Equivalent weight of copper is 63.5 and silver is 2. Okay, sorry, weight of silver is equal to 108. So this gives you copper is equal to 63.5 into 18 upon 100 into 1 upon this upon 2. Okay, so On solving this, you will get 0.0529 gram. So this is C option. This is the right answer to the question. Hope you understood this. Let's move to the next question. Question number 46, the limiting molar conductivities of HCl, CH3, COO, and NaCl are respectively 425, 90, and 125 MHO square centimeter square per mole at 25 degrees Celsius. The molar conductivity of 0.1 m acetic acid solutions is given by this at the same temperature. The degree of dissociation of 0.1 m acetic acid solution at the same temperature is. First, let's consider this reaction. You have CH3COONA with HCl. It gives you CH3COOH plus HCl. Therefore, molar conductivity for the infinite dilution of CH3COOH is given by this CH3COO plus for H plus. This is equal to molar conductivity for the infinite dilution of CH3COO plus molar conductivity infinite dilution for Na plus this. Question number 46, the limiting molar conductivities of HCl, CH3COONA, NaCl are respectively 440, 425, 90, and 125 at 25 degrees Celsius. The molar conductivity of 0.1 m acetic acid solutions is this at at the same temperature. Degree of dissociation of 0.1 m acetic acid solution at the same temperature is. So first thing, if I react sodium acetate with HCl, I'll get CH3COOH plus NaCl. Right. So according to this, the limiting molar conductivity for CH3COOH is equal to this for this ion plus molar conductivity for the limiting molar conductivity for H plus. Right. Now this is equal to, if I look at this reaction, this is equal to CH3COO negative minus molar conductivity for the infinite dilution for sodium plus for HCl. This is M naught plus Cl negative minus for NaCl molar conductivity for infinite dilution of Na plus this for Cl. So now you are given all the values. Let's feed in the values. This is equal to 90, 425, 125. This is 390 MHOCN square per mole. What you have to find out is degree of dissociation alpha. This is given by molar conductivity upon the molar conductivity of the infinite dilution. This is 7.8 given in the question, and this is equal to 390. On solving, this will be 0.02. So the answer to the question, option B. Hope you understood this. Next is question number 47. The rate law for a reaction between the substances A and B is given by this. On doubling the concentration of A and halving the concentration of B, the ratio of the new rate to the earlier rate of the reaction will be as. So you are given that this is rate given as K into concentration of A power M, N concentration of B power N. First rate, let's say this is same, right? Now, on doubling the concentration of A and having the concentration of B, this will be rate 2 is equal to 2A power N, and this is B by 2 power M, or this is equal to K into 2 power n A power n into B power n upon 2 power n, or this is equal to k into 2 power n minus n into concentration of A power n, concentration of B power m. This was equal to rate 2. Now dividing both of them, you have rate 2 upon rate 1 is given by k into 2 power n minus m, concentration A power n and concentration of B power m. This is equal to 2 in k into, this is, not 2 is here, A power n, B power m. They will eventually cancel out. So this is equal to 2 power n minus m. Let's see the answer to the question. This is option C. Hope you understood this. Next is question number 48. In a reaction, the threshold energy is equal to, see, the threshold energy is always equal to the activation energy and the normal energy of the reactants, or the internal energy of the reactants. So definitely you have first option as the right answer. Next is question number 49. Which property of the white phosphorus is common to red phosphorus? Both white and red phosphorus, they burn when heated in air. This is a common property in both of them. So option A, correct answer to the question. Next, it reacts with the hot caustic soda solution to give phosphine. It shows chemiluminescence. No, it is soluble in the carbon disulfide. That's also wrong. We have option A as the correct answer to the question. Next is question number 50. XeO4 molecule is tetrahedral, having which of these options? All right. So you have the xenon over here. Xenon undergo sp3 hybridization. See, xenon is given as this is 5s having 2 electrons. And this is 1, 2, this, 5p and 5d. This is 1, 2, 3, 4, and 5. Wait. 1, 2, 3, 4, and 5. This is your 5d. This is the ground state. And in the third excited state, it will be, this is 5s having 2 electrons, 5p. In the third excited state, it will have 1, 1, 1. And excited electrons will come over here. This is 1, 2, 3, 4, and 5. So this is 1, 2, and 3. 5d, this is your third excited state. And in the fourth excited state, xenon atom will have 8 unpaired electrons. Let's see how. This is, okay, let's see it here. This is, we'll have 1, 1, 1. This is 5s, 5p, and this is 5d. 1, 2, 3, 4. So 1, 2, 3, and 4. This is fourth excited state. So now xenon has 8 unpaired electrons. 1s and 3p orbital undergo 1s and 3p orbital undergo sp3 hybridization. 4 sp3 hybrid orbitals form 4 sigma bonds with oxygen atoms. They are sigma sp3p. So also 4 p pi d pi. Bonds are also formed with oxygen atoms. Bonds also formed with oxygen atoms by the unpaired electrons. All right, so here you have option C as the right answer. Hope you understood this. Next is question number 51. Cuprous ion is colorless while cupric ion is colored. Why? Cuprous ion, which is given by Cu plus, is here is argon having the atomic number of 18. Copper is having atomic number 29. Argon is having 18. So cuprous, that is one electron has been removed from it. Now it will have 28 electrons. So this is Ar argon followed by 3d10. There is no unpaired electron. So it is colorless. While if I'm talking about the cupric ion, that is Cu plus 2. Now it is deficient of 2 electrons. This is 3d9. It will have 1 unpaired electron. Therefore, this is colored. And this is colorless. So that is it. You have cuprous ion has complete d orbital and cupric ion has incomplete d orbital. This is the correct option. Hope you got that. Next is 52 question. The reason for the greater range of oxidation state in actinoids is attributed to which of the following? Let's read. Actinoid contraction, 5F, 6D, 7S levels having comparable energies, 4F, 5D levels having being close in energies, the radioactive nature of the actinoids. Which of these is the right answer to the question? Okay. See, the minimum or the comparable energy gap between 5F, 60 and 7S subshell makes electron excitation very easier. Hence, there is a greater range of oxidation states in actinoids. That makes this as the correct choice for the given question. Hope you understood. Next is question number 53. The geometry and the magnetic behavior of the complex NiCO4 are which of the following? So first of all, NiCO4, this is made up of nitrogen and carbon monoxide, nickel and carbon monoxide. Ni, which is having the atomic number of 28, can be written as argon, then is 3d8, 4s2. Because carbon monoxide is a strong ligand. So unpaired electrons get paired. Unpaired electrons get paired. Hence, configuration will be given as this. Right? So like this, which is sp3 hybridization, somewhat like this. Hybridization. This is your CO, 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 like this. Right. Now, the 4CO ligand hybridization would be sp3, thus the complex would be diamagnetic and having a tetrahedral geometry. So this is tetrahedral geometry and diamagnetic. Option B is the right answer to the question. Hope you understood that. Next is question number 54. Indicate the complex ion which shows geometrical isomerisms out of these four. Okay, if I look at the very first option, this one, this shows geometrical isomerism. The possible geometrical isomers are given like this. Here is your chromium. This is Cl, Cl, OH2, OH2, and this. This can be written like something like this. And Cr, Cl, Cl, you have water molecules over here. And like this. So actually this should be straight like, okay. This is cis poly, cis isomer and trans isomer. So option A is the right answer. Hope you got that. Next is question number 55. Reaction of C6H5CH2Br with aqueous sodium hydroxide follows. In the given reaction, this sodium hydroxide, this is aqueous in aqueous state and polar protic. And thus the reaction will proceed with SN1 mechanism, which is option A, as the intermediate form is, let's see it through a reaction. I'll write down it over here. This is a benzene ring, and here will be CH2Br on reaction with aqueous sodium hydroxide. First of all, intermediate C6, let's write it over here. This is C6H5CH2 plus. This is formed, which is more stable carbocation because of resonance. This is stable cause of resonance. And as we know that the stability of the carbocation is directly proportional to the SN1 mechanism, hence the reaction will follow the SN1 mechanism. And let's complete it. Here will be OH negative. So on completing it, it will be the same. CH2Br. Right. So this is SN1 mechanism, and first option is the correct answer to the question. Hope you understood this. Next is question number 56, which is the correct order of reactivity of alcohols in the following reaction. Right. So the reaction is given by ROH plus HCl in the presence of, sorry, this is, okay. ROH plus HCl in the presence of zinc chloride gives you RCl plus water. Let's write it over here. You have HCl plus anhydrous zinc chloride is your Lucas reagent. Question number 56, which is the correct order of reactivity of alcohols in the following reaction? This is the given reaction. One thing, HCl plus the anhydrous zinc chloride, this is Lucas reagent. It is used to determine the degree of alcohol. The reaction follow nucleophilic substitution reaction in which the OH group is directly replaced by the Cl group. In this reaction, carbocation is formed as an intermediate. Higher the stability of the intermediate carbocation, higher will be the reactivity of the reactant molecule. Since 3-degree carbocation is more stable than 2-degree carbocation, as well as 1-degree carbocation. Therefore, the correct order will be, I can write it over here, carbocation. So the correct order will be given by 3-degree, followed by 2-degree, followed by 1-degree. That is your third option. Hope you understood this. Next is question number 57. Which of the following cannot be made by using Williamson's synthesis? Methoxybenzene, benzyl P nitrophenyl ether, methyl tertiary butyl ether, or ditert butyl ether? Which of these options is the right one? So the two components that should be over here is CH3, 3CONA plus CH3, 3PR. However, tertiary alkyl halides tend to undergo amination reaction rather than substitution, leading to the formation of alkene that is Me2CH2. So you have the option as the correct answer. Hope you understood this. Next is question number 58. Which of the following reactions will yield benzaldehyde as a product? Let's complete all the reactions one by one. This is the first one. Let's complete this reaction. So on reaction of this in the presence of SOCl2, quinoline, H2PDBaSO4. First of all, I'll divide this reaction. So this is COOH in the presence of SOCl2 and quinoline. It will give you, there will be COCl. On further reaction in the presence of hydrogen PDBaS4, this is known as Rosenmund reaction. It will give you benzaldehyde. So option A is the one which will give me benzaldehyde. Next is the second reaction. So you have this reactant in the presence of chromium oxide sulfuric acid. It will give you, here will be COOH. And in this case, there will be no reaction will take place. And in the last one, again, I'm going to break it up. So this is CH3, CR2O3, this is CR2O3, CH3CO2O. Here you have the benzene ring. This is CHOCO CH32. In the presence of hydronium ions heated, it will give me benzaldehyde. So last one, D reaction also gives me benzaldehyde. That makes C option as the correct answer. Hope you understood this. Next is question number 59. In Clemmensen reaction, reduction carbonyl compounds is treated with which of the following? See, in the Clemmensen reduction is, first of all, this reduction is used to convert carbonyl group as like this. You are having C double O bond in the presence of zinc HCl. It will give me CH2, zinc amalgam and HCl act as reagent in this reactant. So first option is the correct answer to the question. Hope you understood this. Next is question number 60. The correct increasing order of the basic strength of the following compounds is. See the correct answer to the question. This is the first and third one, then the first one, and then the second one. Higher the electron density towards the ring, higher electron density towards the ring, higher will be the basic strength. Electron donating group increases the basic strength while the electron withdrawing group decreases the basic strength. So we have a look at over here. This is the right answer, D option. Hope you got that. Let's move to the next question, number 61. The major product in the following reaction is, let's complete the reaction. So this is the reactant and first of all, on treating this, you will get a benzene ring and here will be COONH4 and COONH4 over here. Again, on heating, in the presence of strong heating, like water will be reduction on strong heating, like again it is heated, water will be removed from here and you will get CONH2 CONH2. Again on heating, because we are heating it. So again on heating, strong heating, ammonia will be released and you will get, here will be CNH, CNH, double bond O, double bond O. So that makes Option B. Let's check with the other ones also. Right. That is option B is the correct answer to the question. Hope you understood this. Next is question number 62. Blister copper is impure copper, copper alloy, pure copper, or copper having 1% impurity. Blister copper contains 1 to 2% of impurities. It's obtained, impurities. It is obtained after besmerization of crude copper. So D is the right answer to the question. Hope you understood this. Next is question number 63. PA and PB are vapor pressure of the pure liquid components A and B respectively for an ideal binary solution. If XA represents the mole fraction of the component A, and then the total pressure of the solution will be. See, the total pressure of the solution is given by PA into this is the mole fraction of XA is the mole fraction of component of A. So PA into XA, similarly PB into XB. And I'll let it be like this only, PAXA plus PB. Now the component of X will be 1 minus XA, right? Let's open it. You have PAXA plus PB minus PBXA. This is equal to PB plus, I'm taking XA common, PA minus PB. This is D option. Hope you understood this. Next is question number 64. Following complex shows sp3d2 hybridization. Say among the following, among all of these ligands, F is a weak field ligand making only high spin complexes, which has sp3 hybridization. So that makes C to be the right answer. Option C. Next is question number 65. 2-pentene contains how many sigma and pi bonds? Let's make 2-pentene C, C, double bond, C, C, C. This is 2-pentene. Let's number it 1, 2, 3, 4, and 5 at carbon atoms. H, H, H. H. So now let's see how many sigma bonds are there. There's one sigma bond over here. This is single bond. They have the sigma bonds, and the double is having one sigma and one pi bond. So this is one sigma bond, two sigma bond, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14, and 1 pi. So you have 14 sigma bonds and one pi bond. That makes B option to be the right answer. Hope you understood this. Next is question number 66. For the below given cyclic I'll repeat the question. For the below given cyclic hemiacetal X, the correct pyranose structure is. Okay, this is your X, and see the corresponding. This is question number 66. For the below given cyclic hemiacetal X, the correct pyranose structure is. This is your X, this is hemiacetal. The corresponding aldo pyranose structure is given by this. Over here, here you have a OH group. Here is your O. You are having OH over here also, and here, and here, and here. So this matches, if you look, this matches with D option. Hope you understood this. Next is question number 67. Sucrose is dextrorotatory in nature, but after hydrolysis gives glucose and fructose. Among which of the following is true? Glucose is levorotatory, fructose is dextrorotatory, glucose is dextrorotatory, fructose is levorotatory, the mixture is levorotatory, or both are dextrorotatory. Fine. Yes, sucrose is dextrorotatory, but after hydrolysis, it gives dextrorotatory glucose and fructose, which is levorotatory. Since the levitation of fructose at minus 92.4 degrees is more than dextrotation of glucose at 52.5 degrees. Plus, the mixture is levorotatory. That makes B option as the right answer because third is also correct. The second and the third, they are correct. Mm, sorry, this is option C is the right answer. Hope you got that. Next is question number 68. Allyl cyanide molecule contains 9 sigma bonds, 4 pi bonds, and no lone pair. Okay, before discussing all the options, let's make first of all allyl cyanide. This is C, 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 triple bond. N, your the last one is double bond C, this one. No, this is a ring. Wait. N, and it's like this. Right. Let's complete it. You have H over here. Here is H. Here is H and H. So you are see for one single bond, this is sigma bond. Double bond is one sigma and one pi, and triple bond is sigma and two pi bonds. So let's see it over here. How many this is? This is one sigma and two pi, and over here this is sigma, 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 pi, sigma, and sigma. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 sigma bonds, 3 pi bonds. And about the lone pairs, it's having one lone pair for the nitrogen over here. One lone pair of the electrons over nitrogen. Right. So the right answer to the question is option B. Hope you got that. Next is question number 69. Which of the following pair of compounds is isoelectronic and isostructural in nature? If I look at the options, the second option, the compounds IBr minus and XAF2 are isostructural. Both have the same number of valence electrons, same number of, I'll rewrite this. Both have same number of valence electrons. Both have a linear geometry as they have 3 lone pairs and 2 bond pairs of electrons. Electron pair geometry is trigonal, bipyramidal, and molecular geometry. Electron pair geometry is trigonal, bipyramidal, and the molecular geometry is linear. Right, so you have option B as the correct answer to the question. Hope you understood this. Let's move to the last question of the paper. Question number 17. Which case change in entropy is negative? Evaporation of water, expansion of gas at constant temperature, sublimation of solid to gas, or when two atoms of hydrogen combine to give you hydrogen gas. The correct answer to the question is option D. Let's discuss all of them. Evaporation of water. During evaporation, the state of water is changing from liquid to gas. Thus, entropy increases. The second one, expansion of gas at the constant temperature. When a gas expands at the constant temperature, the constituent particles to move more freely and hence again the entropy increases. This third one, during sublimation, the physical state is changing from solid to gas. Thus the randomness increases and accordingly entropy also increases. Randomness increases, that means entropy also increases. While in the reaction, when two atoms of hydrogen combine to make hydrogen gas, the change in entropy is negative. So that makes option D as the right answer to the question. And with that, we have completed all the questions of the chemistry section for this particular paper. Hope you understood them well. And don't forget to visit our website www.examsnet.com. Here you will find all of these entrance exam question papers with their detailed PDF solutions. Also download our app. The link is available in the description box. So students, keep shining, keep rising high. That's all for this paper. Bye.